If I had to characterize the situation around me today, the one word that comes to my mind is uncertainty. There is uncertainty in politics, there is uncertainty in healthcare, there is uncertainty in economics. Alas, I am a market researcher in telecommunications. Geopolitics is not my cup of tea. I'll stick to telecommunications. Well, there is uncertainty in telecommunications too. What we are witnessing is a flux of technologies at their respective inflection points. On one hand, we have 5G progressing from 4G in fits and starts. Then, on the other hand, we have cloud native network functions or the CNFs progressing from virtualized network functions, that is VNFs, which in turn were progressing from physical network functions, that is PNFs. Lastly, we have artificial intelligence, which is progressing from conventional computing paradigm. How will these three trends affect each other? Today, I'm going to examine the interplay of AI, 5G, and CNF technologies. Good morning, good afternoon, good evening, based on wherever you are in this wide world. My name is Kaustubha Parkhi. I'm Principal Analyst, Insight Research. A disclaimer is in order. Insight Research is a 30-year-old outfit. In 2016, we moved to Bangalore. Since the last 5 years, we have been engaged with technologies that are reshaping the ways in which services, networks, and finally network functions are being engineered. In the interest of time, I will not be dwelling upon the expansions of terminologies used in this presentation. My expectation is that discerning viewers and listeners like you will be conversant with the terms. I'll touch upon what is the present state of the art of AI in cellular telephony. Telephony stack operates in layers. At the top of the stack is the application layer. The higher the layer, the more amenable it is to be software driven. Crudely, this can be manifested not just in the actual technology functions, but also in the OSS and BSS operations that control and manage these network functions. Consequently, these operations were the first to be blessed by AI. I will not delve too much into this, as the advantages that AI brings to the table here are not too different from what AI does in other domains. RPA, as you know, is Robotic Process Automation and NOC is Network Operations Center. As an aside, just to give you the context of how early AI has been making forays in the NOC sphere, I'd like to mention an example. Telefonica launched Huawei's AI-based SoCs as early as 2017. These were in Argentina, Chile, and Germany, with the intention of anticipating possible incidents and black spots. 5G, however, brings about a fundamental change in which networks and network functions are engineered. This change opens doors for AI and ML constructs and applications. What is this change? That change, or the secret sauce, can, as one can characterize it, is this cloud native network functions. The story, as we can say, began in 2018 when the 5G PPP published a white paper outlining its vision for the journey of cloud native infrastructure from conventional web scale applications to the more demanding telco environments. As you know, 5G is more than bandwidth and throughput. MMTC and URLLC, according to me, are the real 5G. These usage scenarios, however, exert contrasting demands on the network. Then you have the NGFI, which demands the network element to be dynamically configurable. In response to these requirements, the telcos graduated from physical network functions to virtual network functions. VNFs ushered virtual machines into network function engineering. VNFs, however, have their limitations, most prominently on their size, which is not really that sleek, and the lack of an acceptable orchestration mechanism. CNFs, or the cloud native network functions, are therefore poised to take center stage in the distant future. CNFs bring in their fold containers and microservices. Orchestration is a major competitive advantage for CNFs vis-a-vis VNFs. Kubernetes, the most widely adopted orchestrator for containers, is a mature product. VNFs, alas, have been hampered by the lack of a solid orchestrator. The advantages of CNF in IT domain can be carried forward to the telecom domain with caveats related to its to performance and latency considerations. The construct of importance here is the microservices. Microservices dissect and granularize applications to a very fine degree. Microservices transform the application structure from a monolith to a collection of logical functions. Each microservice runs independently of the other. Given their portability and agility, containers are ideal vehicles for ensuring that the computing power required for distributed AI applications reaches the destination in an agile and flexible manner. Individual microservices contribute individual logic stands for the conventional software application. AI can also be viewed in a similar manner. An application consisting of primitive algorithms which can also be broken down along individual strands. Typical AI primitive algorithms include pattern recognition, prediction, and regression. Consider the methodologies for wrapping AI/ML models in containers. While being novel and challenging earlier, they are now well understood. DevOps lifecycle tools such as GitLab and Jenkins build jobs can be used for building the ML model and the container wrapper. Container registry and service tools, as well as cloud-based storage services, are mature products. Machine learning platforms such as AWS SageMaker facilitate auto-tuning of models by enabling single-click training of petabyte-sized data sets. The task of distributing the AI/ML build and tuning updates is thus practically seamless. In this context, the isolation provided by microservices lends itself favorably to differential evolution rates of individual primitives. AI microservices, however, need to be reusable and organized hierarchically to facilitate their orchestration sequence. It is now time to examine how the cloud native nature of the 5G core facilitates the entry of AI into the scene. As you can imagine, this is a match made in heaven. Between the core and the RAN, the core was the first to get cloud native flavor. Consequently, the AI ML initiatives in this space are on a much firmer footing. The present day 5G core is beginning to increasingly resemble a bare metal server, making it easier for AI to automate the critical network slicing function set, including the network data analytics function, the network slice selection function, the PCF, and the QoS optimization function, among others. The cloud native analysis intensive nature of the core, the cloud native nature, and the analysis intensive nature of the core throws the market wide open for competition. Practically every vendor emphasizes on the AI driven or the AI compatible nature of their 5G core offerings. This race amongst vendors makes it a tad challenging to identify where the real value of AI is. But we will save that discussion for later. The RAN, on the other hand, presents the ultimate frontier for AI with good reason. Disaggregating the RAN is still a work in progress. Multiple companies and multiple consortiums are suggesting varied approaches. Nevertheless, RAN presents the ultimate prize for AI due to the sheer impact it can have on the operating metrics and quality of experience. The magnitude of applications indicates the upside for AI in RAN. This is, however, easier said than done, as the applications have to be carefully assessed based on the frequency of monitoring and, importantly, their position in the stack vis-a-vis baseband and the RRU. Some of the applications, such as deep learning receiver or air interface design, are clearly slated for distant future, possibly 6G. One way of shifting applications and their priorities is the frequency of their updates. As shown here, Ericsson divides them into three categories. It is easy to visualize that AI will have maximum impact on the more frequently updated parameters. These parameters, however, will take the longest to be brought under the purview of AI ML algorithms. To the right are Ericsson's observations on a redesigned automated ERAN with an Asian carrier for a 4G LTE network. Ericsson reports that the entire automation exercise was performed in a matter of minutes rather than months of work as was traditionally required. There are three bar graphs here. I'll start with the one closest to the center. It indicates the connections in the CA mode using three component carriers. The number of connections increased by 30% when it was in an AI based mode. The middle graph indicates that the data volume carried by any secondary cell increased by 22% in the AI based mode, whereas the last graph towards the end indicates that the downlink cell throughput increased by 4.3%. These are Ericsson's observations for an 4G LTE cell. The crux of applying AI in RAN comes down to how to train the particular models and the algorithms. This particular model in this slide was proposed by Nokia in 2018. By all indications, the training of network stack level algorithms will be more or less analogous with the scheme shown here. The figure shows two groups of use cases. There are use cases number 1, 2, and 3, which can be called as on the top of the RAM use cases. These include use case number 1, that is location or MEC, use case number 2, that is anomaly detection and correction, and use case number 3, that is RRM scheduler, PHY, and BF optimization. Use cases number 4, 5, and 6 form the second group, and they are called embedded in the RAM group. These include use case number 4, that is RRM for the control plane, use case number 5, that is UPQoE OPT, and use case number 6, that's the scheduler. You can see that the second group, that is use cases number 4, 5, and 6, is far more challenging to train than the first one. The success of this model, importantly, hinges on the availability of a granular and a programmable API. This way, the RAN is able to capitalize on the computing power offered by AI and ML hardware accelerators. The RAN Intelligent Controller, or the RIC, is an interesting development. It is closer to an SDN controller in its functionality. It also benefits from the cloud native movement. The RIC was proposed by the ORAN Alliance. It has two variants or two components, I would say. The near real time, it's closer to the action, that is closer to the physical layer, and it can be called the sword arm of this arrangement. It is the executor part, whereas the non-real time is the more analytical of the two. Now, non-real time is where the AI constructs meet the RAN architecture. Now, ideally speaking, this fusion should have happened closer to the physical layer, but you can see that it is fraught with risks. So, non-real time arm is more analytical, and the near real time arm is the more executive of the two RICs. Apart from the commercial offerings from Nokia, Parallel Wireless, and STL, recently the ONF has also come up with its framework for the RIC. So this is one product that is to be watched out for, because it is a sort of a low-hanging fruit that marries RAN with AI. The list of vendors includes RAN solution vendors as well as those offering DAS and RICs. Like the 5G core, these vendors will be able to absorb AI into their portfolio to a greater extent when the disaggregation of RAN attains some level of finality or concreteness. Let's talk about the challenges and the consequent opportunities. The challenge in integrating AI ML with network functions is a subset of challenges that confronts CNFs themselves. CNFs ride on finely defined strands of microservices, which take CNF customization, optimization, and troubleshooting to a whole new level. Microservices are not without their challenges, latency and inspection overload being the key areas. In context of AI and ML, the fine-grained nature of microservices creates an overload of parameters to monitor. One of the reasons why CNFs find traction in 5G is due to the increasingly complex nature of the 5G network. New radio, which by some estimates brings about an increase of several orders of magnitude in network operational data compared to its 4G counterpart. While AI is eminently positioned to handle these challenges, it needs to be fed with proper data sets. Designers need to relook at the very core of their network functionality rules as well as their data collection and storage practices. These rules and practices need to be made amenable to be modeled and being read by AI tools. An additional level of challenge arises based on where the AI application is being employed in the RAN stack. The farther the application from the baseband unit, the more constraining are the latency challenges. It can thus be counterproductive to engage AI for managing real-time configurable algorithms, as we saw in the RIC distribution. An intermediate approach will involve engaging AI in training parameters that are updated less frequently but require crunching of complex and voluminous data sets. In most cases, these parameters are the variables that feed into the real-time algorithms. The training can be facilitated by setting up programmable APIs in the RAN stack at the CU level. AI and its application in RAN will require validation and testing methodology of a different kind, one that is capable of ascertaining that AI is living up to its promised results. This is a major opportunity for network testing and solution vendors. AI is thus poised to play a pivotal role in the cloud native 5G RAN design and management. The speed and the intensity of its progress will be decided by how quickly the RAN datasets lend themselves to AI application training. On a larger note, a broader consensus on the framework of a cloud native RAN is also essential in making it AI friendly. We derived some of the observations in this presentation from a report that we published earlier this year. This report compares and contrasts the progression of cloud native network functions and virtualized network functions in cellular telephony, basically the RAN and the core functions. With this, I come to the end of my presentation. Thank you for patiently listening to me. Now I'm very keen to take your questions and address your doubts, if any. Thank you and have a great day.